Video is on work. Okay, what is work? Work is the transfer of energy. So when you add energy to an object, you take it away. Okay, you've done work on the object. One way you can do work is to apply a force on the object over a distance. So if I push a box across the floor, then I'm applying a force in the direction of the distance. So that's work. Okay, so there's your equation. Work is force times distance. Now the big deal here is the force has to be in the same direction as the distance. So if I hold something up in my arms and then walk across the room, I'm not doing any work. But if I push something across the room, then I'm doing work. Okay. Now if a force is at an angle, then it's not all of the force times distance. It's only the piece that is in the same direction as the distance. So you have to think about the components. I'm not sure how much we'll get into this unit, so I wouldn't worry about that. But if you do, you'd want to find the x component, which would be the cosine to find the force. Okay. Okay, the units of work are the same as the units of energy. They're joules. Okay, remember we named joules. Okay. Now, if you're looking at a graph, then if you apply a constant force over a distance, well, the force would be this number up here, and the distance would be this number down here. So if you notice, that's the same as the area of this rectangle. So the area is the same as the work. This is the work. Okay? Force times distance, the same equation as before. Now, what if it's not a constant force, like a spring force, where the harder you pull, or the further you pull, the harder it is to pull? Right? It's really easy to pull a spring a little bit, but to pull a spring twice as far, it becomes even harder. So then, still, the work is the area under the curve, which, if you notice, that is a triangle. So the area of a triangle is 1/2 base times height. Okay. Now the spring force, you'll need to learn it. You won't recall it from the lab, because we're doing the lab in class next time, but the spring force is F equals kx. That's called Hooke's law. Okay. So if the force is kx and area is 1/2 x times force, and the force is kx, then it's 1/2 x times kx, in other words, 1/2 kx squared. So remember, that's where we get our elastic energy equation, is 1/2 kx squared. Okay. So by the way, the slope of this line is going to be your spring constant. Okay, the slope of that line is your spring constant. Work is one of the ways energy can be transferred. Consider unstretching a spring. An unstretched spring has no energy. To stretch, you have to apply a force to move a distance, so energy is stored in the spring. Okay. So another way of looking at work is it's the energy transferred, which also means the final energy minus the initial energy, right? Or in other words, the change of energy. Work equals the change of energy. Remember how delta E means change. So that is work. Okay, good luck.